Okay, in this video, we're going to talk about magnetic flux in a coil. So we have a long wire formed into a coil with 50 loops of equal size and a diameter of 22 centimeters. It's placed in a magnetic field of magnitude 0.16 Tesla, where the axis of the coil is parallel to the field lines. What's the magnetic flux linked with this coil? And what happens when the coil is turned by 90 degrees? Okay, so let's just go ahead and draw out our coil. So I'm not going to draw out 50 turns here. So let's just pretend that we have more loops than we do. Our coil looks something like this. And we have this front surface that has a circular shape and a diameter, d, of 22 centimeters. So we'll write d equals 22 centimeters. Now, in any kind of problem where you have a lot of different types of variables, you're most likely going to want to go ahead and switch to consistent units, so usually SI units. So let's just go ahead and convert this into meters. So 0.22 meters instead of centimeters. And then we also have a magnetic field of 0.16 Tesla. So B equals 0.16 Tesla. Tesla is the SI unit for magnetic field, so this is fine. And we're told that the field lines are parallel to the axis of the coil. So we have our magnetic field lines going directly into the coil. Of course, the axis of the coil would be straight through the center, so field lines going directly into that circular surface area. So we're also told that this coil has 50 loops, or 50 turns, sometimes it's called. So usually that's given by an n equals 50. Now, magnetic flux is what we're looking for, and that's given by this symbol here, and that's equal to, in the case of a coil like this, and we're looking for the magnetic flux linked in this coil, that's going to be the number of turns times the magnetic field times the surface area that these field lines are going through times cosine of the angle between the magnetic field line vector and the surface. So when I say the surface, I mean any line that would come out of the surface. So in this case, that's just the axis here. So this axis coming out of the surface is parallel with the field lines. And in that case, if you have two lines that are parallel, the angle between them is going to be 0. And the cosine of 0 is going to equal 1. So for us, our flux is going to be n times b times a times 1. So it's just nb times a in this case. Okay, so we want the area of this surface of this circle, this area that the field lines are going through. The area of a circle is, of course, pi r squared. However, in our case, that's going to be pi times the diameter that they give us divided by 2. That's going to be the radius squared. So let's go ahead and plug this in instead. We have n times b times pi times d over 2 squared. So now we can plug in the values that we are given. That's 50 times 0.16 Tesla times pi times the diameter 0.22 meters divided by 2 squared. And this is going to give us a magnetic flux of 0.304. Webers are units of flux. So now we are given two significant figures in our other values, so let's just go ahead and be consistent and round this to 0.30 Webers. Okay, now in the second part of this question, they ask what happens when you've turned this coil by 90 degrees. So let's just move some of this out of the way. So now we have our coil here. And our magnetic field lines, when we turn the coil, our magnetic field lines are going to be perpendicular to this axis, right? So that's going to make the angle between this perpendicular line coming out of the area, the surface area, it's going to make it perpendicular to these magnetic field lines. So that's going to make our angle equal to 90 degrees. And what happens when you have cosine of 90 degrees? That's going to be 0. So that means when you multiply 0 by n times b times a, it means your magnetic flux is also going to be 0. And that makes sense, right? Flux in general, whether it's magnetic or something else, is going to be the amount of something going through some surface. So it doesn't matter what type of surface it is, or what, sometimes it can be the flux of water or some other type of field, but it's the amount of that thing going through a surface area. So when the surface when the surface itself is flat and parallel to the field lines or to the flow of whatever's going in, then nothing's going to go into that surface area. And then your magnetic flux is going to be, or any flux is going to be 0. So this makes sense when you turn the coil by 90 degrees, that our flux is 0. And it's at the maximum amount in this first part of the equation when we have 0.30 Webers, because our cosine is 1, and that's the maximum amount that a cosine can be. It's always going to be between 0 and 1. So hopefully that makes sense. It helps you to understand how flux works in general and how it works in this very specific situation as well. So thanks for watching, and let me know if there's anything else you guys would like to see.